Hi everyone, this is Teres Maria. Today I and Tanya Tommy of 9th semester MSc Physics will be discussing about calibration of silicon diode experiment. The aim of our experiment is to calibrate silicon diode as a temperature sensor, and the apparatus required for the experiment is regulated power supply, temperature controller, furnace, insert containing diode, constant current source, DC differential amplifier, 2 multimeters, and a platinum 100 sensor. Coming to the theory of the experiment, a thermometer works based on the variation of some property of any material with temperature. A platinum resistance works on principle of variation of electrical resistance of high purity platinum wire with temperature. Platinum wire with resistance of 100 ohm at 0 degree Celsius is called PT100. The resistance of PT100 increases by 0.39 ohm for every 1 degree Celsius rise in temperature. Diode thermometer is a PN function diode that can also be used as a thermometer. A small current, that is 1 to 2 milliampere, is passed through a diode in forward direction and a voltage drop is measured across the diode. The current and the voltage across the diode is given by Shockley equation, which is I is equal to I naught exponential of QV by KBT minus 1, where I naught is the reverse saturation current, Q is the elementary charge, I is the forward current through the diode, Kb is the Boltzmann constant, V is the voltage across the diode, and T temperature. The reverse saturation current L0 is not constant for a given device, but it varies with temperature, usually more significantly than kBT by Q, so that V decreases as T increases, which is given by the equation V is equal to A minus Bt. If the current is kept constant, then this forward voltage decreases as the temperature increases, nearly linearly over a limited temperature. The forward voltage of a diode changes with the age of the diode.
So the apparatus required for this experiment, number 1 is power supply. A regulated power supply is a source of DC electrical power, the voltage of which can be controlled between 0 and a maximum value. Such a power supply is required for heating a furnace and maintaining it at a given high temperature. So for this experiment, we set the voltage at 7 volts. So number 2 is the temperature controller. A temperature controller is used to set the temperature which the furnace is required to reach and to maintain the temperature within specified limits by controlling the heating power. So this is the furnace, and the furnace has an insert. This is the length of aluminum rod of square cross section of 1 cm and an axial hole of 3 mm diameter is bored into the aluminum block. On one end of a PT100 sensor is inserted into the block, and on one of the lateral faces of the aluminum block the Si diode is fixed with the araldite. So care is given to see that there is no shorting of any of these elements with the block. The aluminum block is suspended inside the furnace from the terminal disc on a stand fixed to the furnace. So this is the constant current source and it is used to produce a DC current, and in this experiment we are fixing the current at 1 milliampere, and there are two switches over here and these should be at the low current mode. Do not turn the knobs fast at the right end of these ports because the current will increase very rapidly. So this is the DC differential amplifier, which is used to measure a small DC signals for few microvolts. And also at last we use 2 multimeters to measure the voltage. So this is the terminal block of the insert, in which we have an RCA circuit which is marked as TC over here, and there are a pair of banana terminals which is marked as PT100, and another pair of banana terminals are over here which is marked as diode. So this is the temperature controller, in which the two connections here, it is connected to the terminals of the PT100, and the other two connections over here, it is in which one is connected to the furnace of the terminal of the furnace and the second is connected to the negative terminal of the power supply. So the positive terminal of the power supply is connected to the terminal of the furnace and the negative terminal is connected to the positive of the power supply. So the TC socket, it is connected to the I1 terminals of the DC differential amplifier, and the output is connected to the multimeter, which is fixed at 200 millivolts. So the output of the constant current source is connected to the banana terminals of the diode. There is another pair of connection in which it is connected to another multimeter, which is used to measure the voltage according to the temperature change. So switch on all the apparatus. As we can see, the temperature is increasing in the temperature controller, as well as the voltage will be decreasing in the multimeter. And the reading should be taken till 125 or till 130 with a difference of 10 degrees Celsius. So these are the readings we got from this experiment, in which the temperature increases, the voltage decreases. So with these values we plot the graph and we get a exponentially decreasing graph, and with the equation of a straight line y is equal to mx plus c, we calculate the slope, which is m, and the y-intercept, which is c.
As a result of this experiment, the silicon diode is calibrated as a temperature sensor for the operation in region 30 to 125 degrees Celsius according to the equation determined from the experiment. Here we get V is equal to 0.5885 minus 0.002145 T. The graph which we obtain here is a linearly decreasing graph. Importance of calibration of silicon diode. Calibration of silicon diode as a temperature sensor is essential because it ensures accurate and reliable temperature measurements, which are critical in various applications including scientific research, industrial processes, and electronic device monitoring. Some of the major importance are: first one is this temperature dependent characteristics. Silicon diodes have a temperature dependent voltage drop across their potentials when a constant current is applied. This voltage change with temperature is predictable but can vary between individual diodes due to manufacturing differences. Calibration helps account for these variations. Second one is improved accuracy. Calibration allows the diode to be matched to a specific temperature range and application, improving the accuracy of temperature readings. Without calibration, the sensor may produce inaccurate readings, leading to errors in application where precise temperature control is critical. Third one is traceability and standards compliance. In critical applications, essentially in industries like aerospace, automotive, and medical devices, calibration ensures that temperature measurements comply with international standards and are traceable to national or international measurement standards. In summary, calibrating a silicon diode as a temperature sensor is crucial for achieving precise, reliable, consistent temperature measurements, which are vital for the performance and safety of various applications. Thank you.